Solving two-step linear equations is not too much harder than solving a one-step equation, but the thing that makes it a bit trickier is just considering the order of operations. So the way I like to imagine it, think of your pronumeral as having been dressed up or put into some sort of disguise, and our job is to strip that disguise off so that we can see what the pronumeral is equal to. So we want to simplify our equation all the way down, keeping it balanced as we go, so whatever we do to one side we have to do to the other, until we're left with x equals something at the bottom. Now, order of operations, I want you to consider the order that you put your shoes and socks on. You put socks on first and then your shoes, right? And when you go to take them off again, can you take the socks off first? Of course you can't. So it makes sense when you're getting dressed to take off the last thing that got put on first. So similarly, if we look at this x and we tell a bit of a story of what's happened to it, how it got dressed up, we can take off or undo the last operation first. So looking at this one, here I can see that this x has been multiplied by 2, and that turned it into 2x. And then the 2x has had 1 added onto it. Now I can tell that we've multiplied by 2 and then added 1, because if it was done the other way around, if we'd added 1 first to the x, and then multiplied all of that by 2, we'd have to have put it in brackets to multiply the whole thing by 2. And that's not what we have here. So another way you can pick the order is to say this 1 looks like a sort of part that's just tacked on to the end, whereas the 2 is really closely bound to the x, isn't it? It's part of the same term. So the thing that we can disappear first is this bit that's sort of just hanging on loosely on the end. Now, how do you disappear or get rid of plus 1? You perform the opposite operation, which is minus 1. And if you're going to subtract 1 from this side, then you need to subtract 1 from the other side as well to keep it balanced. Okay, if you added 1 but then you took it away again, it's almost like it was never there. So both of these just vanish into a puff of smoke, and we're left with just the 2x on the left-hand side of the equation. And on the right-hand side, we've got 7 minus 1, which of course is 6. Now you can probably spot that if 2 somethings are 6, the something has to be 3. But let's not jump to that. Let's try and hold our good form and continue with a good practice all the way down. Because if we learn the good skills here with our setting out, when we get one that's got fractions in it, it will be easy because we'll have our method sorted. So here, let's again tell the story. What's happened to this x? Well, it's been multiplied by 2. How do you undo multiply by 2? You do the opposite. You divide by 2. Now, the easiest way to do this, and a good habit, is to just divide by 2 this way. The fraction line means divide by, so if we're dividing by 2 here, we have to do the same thing on the other side to keep it fair. And now you can see that whatever x is, if we've multiplied it by 2 and divided by 2, those two things undo each other. They cancel each other out, and we're left with the x all by itself. And we're looking at the answer over here, although we can probably tidy that up a little bit. I like to write the x out nice and tidy by itself, and think, what is 6 divided by 2? That simplifies out as 3. Now, if you've got something more complicated there, you can put it into your calculator to see whether it simplifies. All right, tackling one on this side of the board that's going to work out with fractions. Now, first thing here is to work out the order. What's happened to this x? Well, it's been multiplied by 5, and then the 5x has had 1 taken away from it. So the last thing that happened was minus 1. So to undo that minus 1, we need to plus 1 to both sides. So we write plus 1, plus 1. Now, if we were minusing 1, but we also added 1, clearly those ones have just disappeared. We don't need them anymore. And we just have our 5x on that side. And on this side, 3 plus 1 is, of course, 4. All right, you can see now why we like to have a method here, because it's much harder to spot the answer here than it was on this side. 5 somethings are 4, not as easy. But if we just say, what's happened to this x? Well, it's been multiplied by 5. How do you undo multiply by 5? You divide by 5. Divide by 5 on this side, divide by 5 on this side, and the answer is literally looking at you. It's 4/5. And I'd prefer to just write it out nice and tidy. I can see that these 5s are going to cancel out. So x is simply equal to 4/5. No need for a calculator. 4 divided by 5, there's our answer. Now let's do a couple that have got fractions in them. Now these two equations look really similar, and I've deliberately put the same numbers in them, But it's the order of operations that's different, and that's going to be important because they're each going to have a different solution. So again, tell the story. What's happened to this x? Well, the first thing that's happened, it seems to have been divided by 3. And I can tell because the x and the divide by 3 are sitting there in the same sort of chunk. They're the same term. And then the x divided by 3 has had 2 added to it. Okay, so the last thing that's happened to this x is it was plus 2'd. Okay, it had 2 added. So how do we undo plus 2? We subtract 2. So if we're going to subtract 2 from this side, we have to do the same thing to the other side as well. That'll disappear the plus 2, won't it? It'll be gone. All we'll be left with is the x divided by 3 on the left-hand side of the equation. But on the right-hand side, we've got 6 minus 2, and that's 4. Now, you might be tempted at this point to spot the answer and say something divided by 3 is 4. Oh, I know. Try not to be tempted to do that. Let's follow the correct procedure. X has been divided by 3. How do we undo dividing by 3? Times by 3. Okay, so if we're going to multiply this side of the equation by 3 to disappear that one, we have to multiply this side by 3 as well. So these 3's will disappear, because if you took any number at all and you times it by 3 and divided that by 3, you'll just have whatever the number was. In this case, it's the x. But 4 3's are 12, and we've got there, x must be equal to 12. Now we can check our answer by subbing it in. 12 divided by 3, that's 4. 4 plus 2, is that equal to 6? Yeah, it is. So we must be right. X must be 12. It can't be anything else. Okay, in this one, the order of operations is different. The first thing that's happened to this x is it's had 2 added to it. And then what's happened to this x plus 2? Well, they've been divided by 3. So the last thing that happened was divide by 3. So the first thing we've got to undo is that. Okay, now to undo divide by 3, we need to multiply by 3. And we need to do it to both sides so it's fair. So we need to multiply this whole side by 3. And we can do it by putting brackets around it and just putting a 3 out the front. Don't forget that in algebra we leave out the times signs quite often. If you want to put the times sign in, you can. It's not wrong, it's just not really necessary. But if we're multiplying that side by 3, we've got to multiply this side by 3. Okay, these 3's cancel. That's the whole reason we multiplied by 3 in the first place, to disappear this guy. Okay, so we're left just with the x plus 2 now. But on the other side, we've got 6 3's, which is 18. And if you've got hard numbers to deal with over here, just use your calculator. All right, what's happened to this x now? Well, it's had 2 added to it. How do we undo plus 2? We subtract 2. That'll disappear the 2. But we have to do the same thing to both sides to keep it balanced. So now we're just left with the x, and we know that 18 minus 2 is 16. And we can check our answer by taking it right back to the start and seeing if it will work. 16 plus 2 would be 18. 18 divided by 3 is 6, and that's what we were given in the start. So we can tell that our answer is right before we even check the back of the book.